Hi class, in this video we'll go over the chapters on aggregate expenditure model. So by the way, this is a very long chapter, so if you want, just take it step by step and ask me if any questions. Okay. All right. So first, so what is this aggregate expenditure model? Now before we talk about the model itself, we need to talk about a bit of history. So what happened in the Great Recession or Great Depression? So back in the early 20th century, there was a theory of economics called a classical view of economics. So the classical view says the economy by itself is fully sufficient. That whenever price goes down, consumer will buy more. Whenever economy slows down, so there are more people who are unemployed, wage goes down, so price and wage are fully flexible, and then at a lower wage, company will hire more people, and the economy self-recovers. So this absorption and then self-adjustment process was built into the economy. Therefore, there's little or almost nothing the government can do or should do to influence the outcome of the economy. Because the idea is whenever there's a depression, whenever there's a recession or economic slowdown, economy can self-recover. But that didn't happen during the Great Depression. So it started in 1929, and then it went on for many, many years. The economy just couldn't self-recover. And one problem was that and when the unemployment went up, wage was sticky. So wage wasn't being fully flexible as being predicted by the classical view of economics. And then even when wage did go down a little bit, company was still hesitated of hiring more people. So economy was prevented from fully recovery, and that's because one downside of the classical view of economics is that they ignore this human perception. That what you believe might happen in the future might cause a change in your current behavior, right? And that's applied to everybody. So imagine this. Imagine that suppose that you're the owner of a company, and then today economy is not doing so good. So economy is doing very, very bad. So you have a hard time, selling your stuff. And at the same time, people's wage goes down. So would you be like, I cannot sell everything right now, but I want to hire more people? That wouldn't happen to most companies, right? So that's why this perceptions for consumers, for business, does have a very important impact in the economy, and that's what can really cause the recession to go on and on forever and become depression. And then we come this British economist named John Maynard Keynes. He's very famous for the Keynes view of economics. It is still very much in play, very popular among many policymakers. And then during 2008, the Great Recession, his name was mentioned many, many times because many of the economic advisors under President Obama was acting in accordance to the Keynes view of economics. So Keynes says this, that because people's perception changes in the economy whenever economy slows down, so company wouldn't hire more people when the wage goes down because they couldn't sell everything. Consumer wouldn't buy more good just because it's cheaper because they have no income to buy it. So in those situations, that we must rely on somebody else to help the economy, and that somebody else is the government spending. So if you guys remember what we learned in the previous chapters about the real GDP, which is C plus I plus G plus NX, that G is very important to John Maynard Keynes. That whenever our consumption goes down, whenever the investment goes down, and then we have a lower real GDP, well, then government spending should pick up to recover those losses from those two other categories. So government should be a very important role in the economy, try to smooth out any type of recessions or inflations. All right, so we talk about this. So expenditure. So John Maynard Keynes also says that if expenditure rises, so there are more money spending in the economy, then in the short term, guys, this is very funny. This is in the short term. In the short term, if the expenditure goes up, so imagine government buying more trucks, government buying more books, government buying more everything, then factories will hire more people and produce more output, and the economy self-recovered. And then if expenditure goes down, so if nobody spend money anymore, then company become idle, and then they reduce workers, income goes down, and the output goes down. Now, this might not seem very ideal to many people right now, because why do we want to decrease our expenditure? What's wrong with company keep hiring more people? Well, later on, I'm going to learn something called an inflationary gap. So if the economy become too hot, that might cause inflation in the long run. So that's why sometimes might be in the economy's best interest to slow down a little bit, so cool it off a little bit, right? So then we might want to lower the expenditure for the entire economy. All right, so our aggregate expenditure model is this. It's something you learned before, is that the overall expenditure in the economy is your consumption plus investment plus government spending plus net export. Now this Y here, you're gonna see Y very often in this class. So Y stands for everything. So really, Y is everything. So that's your real GDP. Is your aggregate expenditure. Is all the Y also stand for your disposable income or income. So Y is everything. Okay. So this model says if any of this type of spending increases, so if your consumption increases, investment increases, if anything increases, that will cause an increase in average expenditure. I mean, that's true, right? Because if you go back to this model here, if our consumption goes up, if our consumers spending more money, then of course our overall spending goes up in the economy, right? Same thing for government spending. If government spending spend less money, then of course holding everything else constant, then Y will be going down, right? So this Y, this overall expenditure, depends on the four components listed in here. And then number two, whenever there's more expenditure in the economy, so there's more spending in the economy, then companies must produce more good to meet the demand, right? So higher expenditure buy more stuff, then company hire more people. Lower expenditure buy less stuff, then company hire less people. And then third part says, increased production will help elevate to help reduce level of unemployment rate. That is true, right? Because if company produce more good, they need to hire more people, right? So they hire more employees, then of course unemployment goes down. Now again, guys, remember this is all true in the short run. Later I'm going to study the difference between long run and short run. So one example is that in the long run, if we do spend more money, that might cause more inflation, and then you wouldn't see this reduce unemployment in the economy. Okay, but at least in the short run, it's true. And the last one, an increase in the overall expenditure would lead to an increase in real GDP, and that is true in the short run as well, right? So if we spend more money, then of course we're going to produce more stuff, and then real GDP increases. All right, couple assumptions. So first, assuming the price are fixed. So in the short run, price do not change in this model, and then so price today equal to price tomorrow. And then second, that for certain expenditures are independent of real GDP. So if you go back to this model here, your aggregate expenditure model assumes that whenever your real GDP changes, so real GDP, consumption will change. We're going to talk about why that is later, okay? But this one will change. But investment, government spending, and net export, these three are all fixed. They're independent of our real GDP. So whenever real GDP changes, has no impact on the net export, but it will have an impact on the consumption. Okay, so that's the second assumption. All right, so let's look at this another term. All right, so marginal propensity to consume and to save. So for all the income we have, for all the income you have, think about what you're going to do with it, right? You can buy stuff, you can invest it, you can set it aside, save it. So, but for all the money you have, there are only two outcomes that you can do with it. Either spend it, consume, or save it, right? Consume later, right? So there's no third option. So for all the income we have, so your total income, subtract your taxes, so take away your income tax, equals to your disposable income. Now, disposable income just means that this is your money. You can do whatever you want with it. And by whatever you want, we mean you can either spend it in consumption or save it in saving. Now, marginal propensity to consume, it means that for every additional dollar of income you have, how much of it would you spend it? Right? So suppose that your friends gave you $1, right? And then you're thinking, what should I do with it? Maybe I should spend it to buy with $1. I don't know, maybe dollar value, and then save the rest of the money later, right? So how much of the money you spend it, this percentage is called the marginal propensity to consume. So the number will be somewhere between 0 to 100%, right? So if you have a 0% marginal propensity to consume, that means for every dollar you have, for every additional dollar you have, you're going to save it. You're not going to spend it, right? But if your MPC, your marginal propensity to consume, is 100%, that means if you receive $1 income, you're going to spend everything you have, right? So that will be total consumption, total spending. So the formula is very simple. It's just that your MPC equals to the change in consumption divided by the change in income. Now, again, this Y stands for everything, right? So before it was real GDP, it was aggregate expenditure. In this place here is your income, right? So change your consumption over your change in income is your MPC. All right, so for example, let's suppose your income increased by $500 and then you decide to spend $100. So what is your MPC? The MPC equals to 100 divided by 500. So it's only a 0.2, and that is your MPC. Okay, so just like that. All right, and then on the other side, something called an MPS. So MPS is your marginal propensity to save. So whatever money you don't spend, you must keep it somewhere else, right, to save it, and that is called an MPC. So for the same, and the formula is also very simple. It's your change in saving. So S stands for saving divided by change in income. So for example, the one we had before, that if you have $500 of your income increased, and then you're going to spend $100, that also means you're going to save the other $400, right? So what's your MPS? Your MPS just equals to the $400 saving divided by $500 income. That should be a 0.8. That's supposed to be an 8. Okay, so 0.8 is your MPS. All right, and then one more thing you guys need to know is that your MPC plus MPS equals to 1, and that's always true. Okay, so MPC plus MPS is always equal to 1. All right, now let's look at our consumption and saving together, or consumption income. So if you want to plot your consumption on a graph, with respect to income, then you're going to start with this point A. Now this point A, that means if your income is at 0, you will still spend some money to buy stuff, right? So this A here is called autonomous consumption. So think this as your basic need to survival, right? So bread, water, maybe milk, right? So shelters, right? So the stuff you must spend money on to survive, regardless how much your income is. That's called an autonomous consumption, right? So even at a $0 income, we still need to spend some money to buy the basic need. And then as your income increases, so income goes up a little bit, and then consumption goes up a little bit, right? So if you keep doing this, so income goes up, consumption goes up, and then you have this nice little line over here. Now this line is called a consumption schedule. So the consumption schedule measures that as your income increases, how much your consumption changes. That's called consumption schedule. Okay. So we're also going to introduce here a 45-degree line. Now this 45-degree line is very special because at this 45-degree line, we're saying that on this line, anywhere on the line, that your consumption is equals to your disposable income. So DI stands for disposable income. Now let's think about what that means. If your consumption is equal to all the money you have, then how much is your saving? Nothing, right? Because so on this line, on this 45-degree line, your consumption is equal to all the money you have. So for any economy who is on this line right here, on the blue line, that means this economy is not saving any money at all. And then I'll show you why this is important. Now, once you put two lines together, so once you put your consumption schedule and then the 45-degree line together, different section of the consumption schedule will show you how much your saving is. So let's suppose we take this $0 again. So $0 income. At the $0 income, we have no income, but we have a consumption here, right? So how is it possible? Because we borrow money for it, right? But in this case, we don't call this borrow money. We call it this saving. So the negative of saving, right? So anywhere that if your consumption schedule is higher than your 45-degree line, this is this saving. That means we borrow money. And anywhere if your consumption schedule is below your 45-degree line, then we're saving money here, right? Because we have more income, so our income is actually high, and then consumption is low, then this difference vertically, that is our saving. Okay, so from this intersection, anywhere to the left, you have this saving, that means you borrow money. To the right, you have saving, that means you're saving money because your income is more than your consumption. All right, so now for your saving schedule, same thing, like similar to what we saw before, but we're going to draw a zero line here. So anywhere to the positive, this is saving. Anywhere to the negative is this saving. So according to this diagram here, at this point to the right, we have saving because your saving is positive, right? And to the left, you have this saving because your saving become negative. And then if you compare this to our consumption schedule, so if you put the two lines together, this intersection is the same thing as your original intersection between your consumption curve and then the 45-degree line. They're the same intersection, right? So this portion here, we have this saving, and this portion here, we have saving when saving become positive, and your income is more than consumption. Now, next, let's talk about investment. So for investment, this is the investment made by companies, right? To build a new factory, to buy a new truck, to start a new project. And then for every company, when they're making a decision on investment, they must think about something called an expected rate of return. So how much is your profit that you expect to have from your investment? Now, this expected rate of return will be stated in the percentage form. So let's say 10% or 15%. So let's suppose you have a project that have an expected rate of return of 15%. That means you can make a 15% profit on the project from how much your initial investment is, right? So suppose you put in $1,000 and then the expected return is 15%. That means you get back $1,000 plus 15% more from the $1,000, right? So this is the profit, right? So the higher the expected return you have, the more profitable this project is. And then whenever the company are deciding whether or not to invest in the project, they always want to compare, what is our expected return and then what is our interest rate. Now for this interest rate, think this as company are borrowing money to start a project, right? Suppose you want to open a business, and let's suppose that you expect that for your business every year you can make a 10% profit. And that's pretty good. But what if you must borrow money to open a business? And then when you go to the bank to borrow money, and the bank will charge you a 15% interest on all the money you borrow. Well, that's not good anymore, right? Because if you only make a 10% profit, that's not even enough to pay for the money you borrow, right? So to make this math work, that your expected return must be more than the interest rate. So imagine the bank says, oh, we're going to charge you a 5%. Hey, that's great, right? Because for our business, we can make a 10% profit, and the bank only charge a 5%, then let me borrow money from the bank and open a business, right? So as long as your expected return is more than your real interest rate, company will invest in this project. But if it's less, then they wouldn't do the project at all. Okay, so your expected return or your investment is actually depends on what the interest rate is. So at a higher interest rate, so if interest is very, very high, so 25% interest rate, then companies will have a lower level investment, because it's not that many projects can earn, expected rate of return that's more than 25%. But if your interest rate is very low at only 5%, then there will be a bigger level investment, right? So lower interest rate is cheap to borrow money. Well, that's great. I will borrow money to open a chicken fried rice place, right? So how much money we borrow to open business, our overall investment depends on what the market interest rate is, and it's always negative, right? So higher interest rate, company borrow less money. Lower interest rate, company borrow more money for investment. So our investment depends on the interest rate, and that's very important. Remember that. Okay, so investment for any economy depends on interest rate, not your GDP. So GDP doesn't have any impact on investment. Only the interest rate have an impact on investment. Okay. All right, so let's go to the next slide. All right, so for consumption here, this will change whenever real GDP changes, because real GDP also think real GDP as the equivalent to our income, right? So if your income goes up, well, consumption will change, right? So remember when we talk about this MPC, right? So if your income goes up, then according to MPC, a portion of your income will be spent on consumptions. So consumption will increase as the real GDP increases. So consumption depends on the real GDPs or income. Now for investment, it doesn't. Remember, we just talked about this before. Investment depends on the interest rate. Government purchase, it doesn't depends on that, because government purchase depends on the government policies, not on how big the GDP is. And then net export. Now, net export is more complex than what we tend to talk about in this chapter, because for net export, whenever real GDP increases, there are actually a couple of factors that's working against each other within net export. So for one, if your real GDP is increasing, so the overall economy has more income, then we tend to buy more import. We tend to buy more, cars that's made in Europe, cars made in Japan, right? At the same time, if your real GDP is increasing, that means you are producing more goods. So you might also have more export. And then net export equals to so net export equals to export minus import, right? So if your real GDP increases, then you have two factors here working against each other, right? So we don't know what the end result is. So just for simplicity, we're gonna assume that net export is independent of real GDP. So real GDP has no impact on our net export. All right, so when you draw this diagram again, so consumption schedule, and then our 45-degree line, right? So you put it all together. So just what we saw before, and then if you adding on to each layer of your aggregate expenditure model, so let's add in investment. You adding investment, that's supposed to be I. So you adding investment, it will shift higher a little bit, right? So you go to a higher level of aggregate expenditure. You adding government spending, increase a little bit. You adding your net export, increase again a little bit, right? So overall, once you take the entire aggregate expenditure model, so C plus I plus D plus X, you're gonna have the true aggregate expenditure model compared to our real GDP. Then at this point here, economy is under full employment. Full employment means everybody who want to have a job. We're doing the best we can. But if anytime you are below this level, we have a recession. Anytime you are above this level, we have expansion or inflation. I will show you that later. Okay. All right. So the next concept is called a multiplier effect. So sometimes when you're spending one additional dollar in the economy, that might be translating into more than $1 of total overall expenditure. So so let me draw a little diagram for you. Let's suppose we have two people, right? So let's call them person A and person B. Now, for person A and person B, they're the only two consumers or individuals in the economy. So let's suppose we said, hey, person A, you go buy something from person B for $1, right? So $1 is spent from person to person B. Now, once the person B has this dollar income, they have more money. And what does he do? He will spend it to buy something from person A, right? So this $1 will be flowing back to our person A. And then what happens to person A once he has the dollar again? He will spend the dollar again with person B, buy something from person B, and then person B will buy something from person A again for $1. So this $1 can be flowing, back and forth, back and forth, back and forth, back and forth between A and B forever. So theoretically, that this $1 can become, infinite amount of transactions in the economy if the money is keep flowing between two peoples. So that's called a multiplier effect. That with just $1 additional spending by one party, how much total spending you have, and that difference is measured by our multiplier effect. So it multiplies by different amount. Now, of course, it wouldn't be infinite, right? Otherwise, you wouldn't have this multiplier number. So the multiplier effect, by definition, so the concept that additional dollar of expenditure will result in the creation of more than $1 worth of real GDP. And then for the multiplier effect, you have two different formulas for multiplier effect. The first one is your multiplier effect on the regular consumption. So whenever your regular expenditure changes, so your consumption, your government spending, your investment, net export. So whenever this 4-factor changes, the multiplier formula is this. So 1 divided by 1 minus MPC. So let's suppose we're saying the MPC is going to be 0.6. So 60% of consumption or whatever extra income you have all goes to our consumption. Then the multiplier would just be 1 over 1 minus 0.6. And then the answer should be 2.5. Right? That means every time if any of the four factors, your consumption, government spending, investment, and net export, if any of this increase by, let's say, $1, then this $1 can be translated into $2.5 of total spending increase in the economy. That's the multiplier effect. Okay, so your change in total spending, the change in total expenditure, equals to the multiplier effect. So the 2.5 times the change in any one of the component change. So $1, $1,000, $2,000. Okay, so that's the multiplier effect on the expenditures. The other multiplier effect is a tax multiplier. That when think about tax as a drain on the economy. Now it's not supposed to be, but according to this model, it is, because every time you have a tax, we're taking money away from the economy. Not even though it's given to the government, but we don't know what they do with it, right? So for now, just assuming that's a drain on the economy. So with the tax, we're taking money away from the economy, and that's bad for the economy. So the multiplier effect for tax is this: it's the negative MPC divided by 1 minus MPC. So if you go back to the number again, so if you have an MPC that's equal to 0.6, then this equals to negative 0.6 over 1 minus 0.6, and this would be negative 0.6 over 0.4, and this would be a negative 1.5. Now, what that means every time if your tax increased by $1, then your overall spending for the economy would decrease by 1.5. I mean, that makes sense, right? Because if you charge a higher taxes, then of course there's less money available to spend in the economy. So tax increased by $1, then the overall spending in the economy will go down by 1.5. Now, if you reverse it, if your tax goes down by $1, then the overall economy will have an increased spending of 1.5. So between tax and then your overall expenditure, they're inversely related. So higher taxes, lower expenditure, lower taxes, higher expenditure. So this is true here. So your total expenditure, your total change in expenditure will equals to the multiplier for tax, which is again the negative MPC over 1 minus MPC times the change in tax. right? So either increase or decrease how much our tax is. All right, so the next section is the math behind it. Let me see if I can show you this using my notepad. All right, so our aggregate expenditure equals to consumption plus investment plus government spending and then plus net export. Our consumption equals to the autonomous consumption, so whatever spending you must make, plus, so this is these are on the necessities, so like your shelter, your food, your water, plus MPC times your income minus your tax. Okay, and then also we know that your aggregate expenditure equals to your total income for the economy. So let's put all this together, right? So your aggregate expenditure, this is also your income equals to C is all this over here. So autonomous consumption plus MPC and then times Y minus your tax plus I plus G plus NX. And let's simplify it, right? So again, Y equals to your autonomous consumption plus MPC times Y minus MPC times tax plus I plus G plus NX. And then I'm going to move this one to this side, right? So Y minus MPC, Y equals to autonomous consumption. I'm going to leave this one at the very end, right? So plus I plus G plus NX, and then minus MPC times tax. All right. Okay, so again, simplified. So this is 1 minus MPC times Y equals to same thing. So A plus I plus G plus NX minus MPC times your tax, and then move this one to this side, right? So there you're gonna have your Y equals to 1 over MPC times A plus I plus G plus NX minus MPC over 1 minus MPC and tax. Right, so there you have it. So this part here, that's our multiplier on the aggregate expenditures. And then this one here, especially with a negative sign in front of it, that's your multiplier on tax, right? So that's the math behind it. All right, let's go back. We're almost done with this chapter. So let me show you how this actually changes whenever there's a component change. Oh, where was I? There you go. Let me go down. There are a lot of slides for this chapter. There you go. All right, so suppose we have this economy. The aggregate expenditure is at 15, and then we have our economy currently setting at 400 real GDP. Now, if this increased by a little bit, so only increased by 50, so it goes from 400 to 450, then what you're going to have is a much bigger change for our real GDP, right? So see that? So change in the investment of $500, but this changed our overall economy by 100. Now, why that is? Because of multiplier effect. So this economy probably have a multiplier of 2, right? So increasing investment will lead to an increase of 100 in real GDP, according to our multiplier effect. All right, last section. So the difference between the inflation and the recessionary gap. And what you learn from previous chapters on the business cycle. Whenever real GDP is increasing, that's expansion. Whenever it's decreasing, that's recession. We can also use our aggregate expenditure model to show that. So on the aggregate expenditure model, so right now we're at a full employment. So right now the economy is doing great. We're at 500. And then let's suppose something happens, right? So let's suppose our real GDP goes down by 100. So it's went from 500 to 400. So now we're operating at this level. So at this level here, this gap here is called a recessionary gap. So how much we're away from our full employment, that is called a recessionary gap. So by definition, it's a difference or gap between the expenditures when the real GDP is below the full employment or the full employment real GDP. So whenever you are less than the real optimal level of 500, that's called a recessionary gap. Now, vice versa, if it's more. So let's suppose the economy goes up. So before, again, was at 500, that was full employment, but now we increase to 540. Then this difference here, it is called inflationary gap. So different that whenever your real GDP is above the full employment level. Now, again, this sounds good, right? So who doesn't want to be above the, whatever you can be? Why don't we want to operate at full potential, right? So later chapters, I will explain to you why that is. Why is it too bad? But for now, just remember that if you are operating beyond your full potential, this might cause an inflation problem in the future. That's why it's called an inflationary gap. So later on, this will cause price level to go up by a lot. Okay. All right, guys. So that's it for this chapter. So a lot of information. Have any question, let me know. Okay. Good luck. Bye-bye.